Hello YouTubers. This is another video where we continue to talk about the fundamentals of building ASP.NET Core applications. In the last video we talked about brokers and services and how you want to abstract away if your brokers have hard dependencies on an external library that dictates its own models. You want to make sure that you build a service that converts those existing external models into internal models that your other services could work with. All right, that's great. Now we want to continue to talk a little bit about brokers and services. There's a lot to talk about when it comes to that, the mindset that you should have while approaching building a new solution or implementing features in an existing one. But today I mainly want to talk about the language that you need to use from a naming convention perspective when you're building methods for brokers versus what you need to use when you're building methods for services. And I'm going to show you that in a very specific, detailed way, following tests and everything. But before we start talking about that, let's talk about it from a high-level perspective. Every class should speak the language that what it's consuming understands, meaning that brokers speaks technical language because it interfaces with a database or a notification system or whatever. So it says send notification, add student, remove teacher. It's very specific CRUD operations technical terms, right? But services, they are responsible about your business logic. Therefore, they should speak a business language. They should speak a business language. So what does that really mean, and how does that look like from a naming convention perspective? We could talk forever. Let's write some code and see how that goes. Let's go in here and build an ASP.NET Core application. And let's call it Washington Schools. And because naming convention is very important, you need to, like, your solution need to maintain the name of the product, but whatever you're building under that solution should be a branch of what the next step would be. Like, this is web, this is mobile, this is whatever the product you're building may be. So let's create that. And then we have all of that. Do we want to build an API or a view? I mean, we're not going to use either, but that's fine. Let's use a view just to show you the entire thing. And here we go. Here we have a good, nice project in here built for us. So like we talked the last time, we're going to create brokers and we're going to create services. Right? And now, everything starts from the model. Every application start from the model. If you're starting from scratch with a new feature, think about your models and then think about all the circles around that model. How to persist the model, how to manipulate the model, and how to present the model. Brokers, services, controllers, and views. All right, so if we're building a school system, then you would expect that we want to persist students. So we need a student model, and this student model will have, let's say, an ID, and it will have a name, like that. All is good and dandy, fantastic. All right, now we want to add the student. We want to communicate with storage to save that student and retrieve that student and all that kind of stuff. So let's go into brokers in here and create a new interface. And let's call it iStorage Broker. Why storage? Why it's not iStudent Storage Broker? I'll come back to that one, right? But we're interacting with storage in general. It's one database, one broker, and the broker interacts with the database and pulling stuff from the database, all said and done. All right, so your storage broker basically will have one function. Let's make it asynchronous. So let's call that add student async. So this one function is an asynchronous function that adds students to the database asynchronously. And then we're missing a model, so control period, move the model, put the reference, all good and dandy. All right, let's implement that guy, right? let's go in here and say I actually want to persist stuff in the database, right? So let's go in here and say this is my class. This class is a storage broker. It implements a couple of things. The first thing it implements is a concrete class called DB context, which is an interaction with the entity framework to communicate with the database. But it also implements iStorage broker, right? You start with the concrete and then go to abstract. Control period, it will put a sample implementation of your class. All good and dandy. Now we want to define a class member, a class property that is handling all the students' operations, like this. So this is all the students' stuff that we need to work with, right? Feel free to make it private. We want to hide this away from the world. That's totally okay. I'm gonna make it private in this particular instance because I don't want anything in the outside world to interact with my students' property on my storage broker. Instead, they have to interact with my methods in here, right? All right, and your method is pretty straightforward. Await this dot students dot save. Actually, I don't need to do this with this because it's a class property. It's just private. So students await students dot. Do I have to say this? This dot okay, fine. So this dot students dot add async, right? And we're passing in that student object like this. All right, because it's asynchronous, we want to do an await, but we also want to make sure that this is asynchronous like this. So this add student async, and then await again. This dot save changes async. Save changes. This is coming from DB context. Whatever is in the context, it'll pick it up and save it in the database. So just like that, we implemented a functionality that saves students in the database. Now, people here have two opinions, right? Some people here say, when you save the student, you should return the student, right? Some APIs, when you call the API and you persist something, it gives it back to you. Some people do that, and some people give you just the ID of the student that you saved. They tell you this is the ID of the student that you saved in the database, and some people just say 200. They say, okay, I saved the student, we're done, right? Either way, it really depends on your business logic. I don't really have a hard opinion about whether you should return what you're persisting or not. It's very useful when it comes to testing standpoint, but you can still test your software even if it doesn't return anything, right? So like we said, look at the brokers. The brokers are a very thin layer that interacts directly with the outside world. As soon as you start seeing if else in your broker, you're starting writing if else, that means that you are unable to distinguish between what is a business logic and what is a broker interface, right? Anytime you see if else, that means you need to move immediately to the service layer, because if else means you're using a business logic. You're starting to do some logic in there that you can't reach by testing, because we keep our brokers something really, really thin. All right, so we did a student persistent. We have student storage broker that persists students, which is fantastic. Now, the next step would be, we want to go in the services layer and create a new service. We're going to create an interface for a service and call it iStudents service. And this iStudents, this is the part that I want you to pay attention to. When you're building business logic, your methods should speak the language of business logic. You can't go on the business layer and say add student and then you're calling add student. That on the broker, that doesn't make sense. Then why are you building business logic class if your class is not gonna implement business logic concepts? In the schooling system, there's no such a thing as add students. A parent doesn't go to school with their kid and say, hey, please add my student to your school. Nobody says that. In reality, a parent would take their kid to school and say, register my student my son in your school. I'd like to enroll my son in your school. But nobody says add my student or add my son to the school. Nobody says that. So your business logic should exactly be reflective of that. So you're having here task register student async, and it takes a student model and persist it asynchronously by passing it forward to the broker. So the language here have changed. When you delete a student from the database, you don't really delete a student from the schooling system. You say expel student. Expel student, right? Sometimes the information may match, like modify information or update student profile, which really comes down to update student. So the language from a business perspective is going to be a little bit different than the language on a broker technical level perspective. And that reflects in everything, and I'm going to show you now how that works. Let's go into the service here and just write an implementation real quick. So I'm going to build here a student's service, which you have guessed it, it implements student service interface. And it has a dependency. See, I'm not writing any tests because I'm not writing any logic yet. Once you see me start writing some logic, stop me. So private read-only iStorage broker. Here's my storage broker. And then you're taking in a dependency. Here's your dependency injection magic, and then we're assigning it like this. Now let's stop here for a sec. A lot of people, when they define excuse me, private class members, they go and do that stuff. They go here and do this underscore, and then they go here and reference that as underscore. This pattern does not follow the C# standard. If you look at the C# standards, any book, literally any book written about C# standards, if you go to the language specification for C# that was written in 2002 at the inception of C#, you will notice that every class member, private member that they have does not have that underscore stuff. So where did that underscore stuff came from? A lot of people migrated or moved from C++ development to C#. And they carried some habits with them as they're coming from C++, because C# and C++ are very similar. People said, well, we used to define our constants that way. We used to define our private class members this way, so we're just going to do the exact same thing in C#. That's not okay. I know it's very, very popular, and it might be one of the controversial subjects, but if you really want to write clean C# code as the creators of C# intended it to be, you probably do want to use that underscore stuff. You probably want to go and say this dot storage broker, and that distinguishes your class member from your input parameter. All right? All right, we made that point clear. Now let's go and write some tests. I'm going to create a new project in here and pull in all the stuff that we talked about last time. Let's create a new project. Let's call it XUnit. Oops, what did I do? XUnit project.NET Core. And then the exact same way from a naming convention perspective. So Washington schools.web.tests. And then I want to create the exact same structure here. So it's going to be a folder called services. And then I'm going to move that unit test in there. I'm going to call it students service. And then unfortunately it used to service tests. Yeah. Unfortunately it used to rename your class when you rename your file. But I don't know if that's an option I need to do or not. I'm not sure why it's not working. Anyway, students service test, and we need to write a test. Now, when you're naming your test, A lot of people use two different models. Remember how we talked about you need to break your test to given, when, then, right? The exact same way when you're naming your test, some people say when X happens, then Y. And some people should say should do X when Y. And some people say when Y should do X. To me, I don't care as long as you are explicitly stating your case, right? So in that case, you should say should uh, um, uh, persist student when student is passed in. Something like this. Should do that when that happens, right? And you don't have to go look so far because you already have the when and the then. So you're basically saying the case and the verification. The given is just a setup, so you don't care about it. All right, so we want to persist a student when a student is passing. Let's go and add in a bunch of NuGet packages. So what we want to do here, we want fluent assertions, so we can verify a student and a student. I'm not sure we're gonna really need that. We'll come to that. And then we want dynamics. We want the object filler just to create a student for us, so we don't have to waste time creating random students. Like I said, we're testing behaviors. We're not really testing particular values. Your test should be like tubes. They're just testing that things go through correctly. And the last thing we want is mock, obviously. So mock, MOQ. Here's your mock library, add it in, and all good and good. All right. All right, so that means let's go and mock some stuff. So we want to mock storage broker, mock, naming convention, very important. You're calling it a mock because it's a mock, it's not a storage broker. And then that is of storage broker. If you do control period, it will find the project that has this in it and fix it for you. Even if you do some misspelling, it'll fix it for you. Visual Studio is very, very powerful. And then we want to do student in here, a student object. Here's our student that we are going to persist in the database, and now we could use dynamics, the object filler, and pass in a student in here, student, something like that. And then create a student for me. Visual Studio is still trying to catch up with me. So funny. So all right, so there you go. So someone might ask me, how come you used the var here but you used student here? I'm going to tell you why I did that. Because var here, it's very obvious the right side of the equation here. The right side here is very obvious what the type is. It's mock iStorage broker. So if I use that, if I go in here and say this is this, it's super redundant and annoying because you're already saying the same thing twice. So instead use var. Use var when the right side is clear. Use var when you don't know what's coming from the right side. Let's say you're calling an API and it's sending you back a JSON object and you didn't serialize it yet, so you don't know what it is. Put var in there, makes sense. Do not use var if you're calling a method that is not explicit about what it's returning. Like here, we're calling a method called create. We don't know what this method sends. If I put here student, I'm seeing new filler student, but I'm putting student in here. It doesn't make sense. Or putting var in here. So I'm using student in here to say whatever comes out of this is going to be of type student. All right? All right, all good and dandy. We just want to mock our storage call. So this is storage broker mock setup. I'm going to go in here and say broker.add student async, and then I'm passing in the student, and that'll be it. It doesn't really return anything, so I'm just going to stop there. I don't have to do anything else. Fantastic. Now, let's test our stuff. So var students service equal new student service. Here's our student service, and our student service has a dependency on storage broker. So I'm going to go here and say storage broker mock.object. All right, and then because it's an awaitable, we're going to go and say await student service dot, let's say why it's mad at us, because this guy is not asynchronous first. That's one part. And then student service dot register student async, and we're passing in the student. So now we have built our case. This is when the action happens. The last thing you want to do is verify. Now someone might ask me a question. Said, well, you built your broker method and your service method to return nothing. They're returning tasks, which is the equivalent of void after you resolve that task. That's the equivalent of void. So how does that make any sense, right? What you can do here is that you can verify that the method that you're calling has actually been called. So you could go here and say storage broker mock verify. Here's broker, and verify that this broker with this particular student, add student async student, has been called exactly one time. Times once. Here is a fully driven, test-driven application. We have just written a test in here, and we want to verify that. So I'm going to go ahead in here and do Control-RT. And it blew up because there is no implementation. Now we could go here and say this dot storage broker dot add student async, and then we can pass in the student, and we can go here and await that call because it is an awaitable call. So async task, all should be good and dandy. If you go back to your test, Control-RT, it should now pass. It should give us the green light now. And this is the green light. If you look at Test Explorer in here, you should be able to see your test. Now, someone might ask me, I've seen some people say, I don't see the Test Explorer in Visual Studio. Where's the Test Explorer at? If you go up there in Tests, and then click Windows, you can see the Test Explorer right there. Control-ET will show your test. Control-ET will show your Test Explorer. If I hide it and do Control-ET, or maybe if I close it completely. Let's close it. Yeah. Control-AT. What did I miss? Control-ET. Yeah, it should. Control-ET. No background task. I don't know. Am I reading it wrong? Control-AT. Control-ET. I don't know. It's not working. And we're just going to have to do it this way, I guess. Test Explorer. All right, so we have Test Explorers. Let's pin that just so we can keep an eye on our Test Explorer. So something for the people that are writing code. How do you know your method is clean? The method is clean when you're looking at your method within one view and you don't have to scroll up and down and right and left in order for you to be able to know what the method is trying to do. Okay? If the method is doing too much stuff, then wrap them up in methods. And have that main method that calls all these little methods just have lines, that describe to you what it's trying to accomplish. All right, so we have that passing, all that good and good. You noticed that in the storage broker level, you're saying add student, but on the service level, you're saying register student. This should also reflect on the exceptions that you're throwing. Let's go ahead and write some exceptions. In the broker level, if you do a try catch, excuse me, and this, I think DB update exception is what this guy is throwing here, exception. So Entity Framework will throw a DB update exception, right? And it's going here and say throw exception. Like this, right? The problem here is some people, you'll see some people do throw like this, and you'll see some people do throw EX like this. First of all, I hate that EX part. You need to be very explicit about what you're throwing. So let's say DB update exception like this. It should be the name of the thing. All right, what's the difference between this and this? This guy in here continue to propagate the exception that's generating from lower layers. It's very useful if it happens on the service layer, for instance, and you want to propagate what happened from the broker or a service behind it. Go ahead and say throw. So it will continue to propagate all the way up. If you want to start your exception stack from here, irregardless of what happened on some dependency that you don't have control over. Let's say you're pulling in SynGrid or pulling in some library from the outside world and it's throwing an exception. I have no interest in the stack trace that's happening on that external library that I have no control over, but rather I'd rather throw the exception from that broker level. In here it makes much more sense. All right, so this guy is throwing DB update exception, which is, if you look at the methods that you're using with the entity framework, the people who wrote those libraries are diligent enough to update, to have the documentation tells you what kind of exceptions this method is going to throw. What kind of exceptions this method is going to throw. So in here you'll see it's saying DB update exception or DB update concurrency exception, right? One of them happens when you're trying to update multiple things concurrently at the same time. We don't have to worry about that right now. That's a little bit too advanced. Let's do with the DB update exception. Let's say some exception happened of some sort, right? But that's on the broker level. Now let's go to the service level. On the service level, I'm gonna have to go here and create a new folder. I'm gonna call it exceptions. And inside that exceptions folder, I'm gonna create my own local exception that I deal with. And that exception is called student registration failed exception. And that new exception inherits from exception, the main exception class. Student registration failed exception. The language is changing, which means that on the service layer, when I get a DB exception, I transform, I map that, and I convert that into a business statement. I could not register this student. I could not register this student. All right, let's make this test driven. All right, let's go back here to our test and say, I'm going to write a new test. Fact, public async void should throw student registration exception when storage fails. Something like that. All right. Now this looks really long because I am at 205, but actually this code looks like this in the real world to me when I'm writing code. Very, very small and precise. I can read the entire thing so easily. But for the people that asked me to make the code a little bit bigger so they can read, there you go. All right. All right. Should throw student registration exception when storage fails. All right. So we're going to go here and do given, when, then, the exact same thing. Now, something that you can do, instead of having to reinstantiate these things every time you run your test, we know for a fact that you need a student and we know for a fact you need this and that. Why don't you use the constructor and create a private class member? Let's call it mock storage broker. And with every test, it will reinstantiate that object for you. So you only write it once and run it multiple times across any number of tests you may have. So let's take this guy here, and because it is a private class member, let's go say in this dot storage broker mock, and then let's say this guy equals this. I overcopied and overpasted. There you go. So now things are a lot cleaner. Now you don't have to re-declare the mock every time you want to instantiate a new storage broker mock. All right, so let's use that in here. We're just gonna stub it, but this time when we're stubbing this guy, it's gonna be a little bit different. I'm gonna come to you to this part. All right, let's go back to this one. Student. We could also move that guy to the constructor if we want. We could keep it here. It's up to you. So this is filler student, and I'm creating a new student. Create like this. But then the mocking of the storage broker is a little bit different. So this dot storage broker mock dot setup, we want to say broker dot add student async. When you pass in that student, make sure you throw asynchronously a new exception. So what kind of exception are we throwing in here? Let's clean up our code a little bit. When you're taking a new line, take just one tab. And if you're going to take another new line, then take another tab under it. So that means I know that this line here, these two lines belong to this guy up there. That makes your code a lot cleaner. If you have to go all the way up down here, 5, 6 lines, you probably should break down your method into smaller methods. So anyway, that's just a side note. But now in here, you're saying I'm throwing an exception async. The kind of exception you want to throw is DB exception. DB exception, you cannot do a dynamics filler with DB exception because it needs the parameters. And dynamics doesn't know what to pass to it. So instead, let's create it. So let's say this is a DB update exception, which is a DB update exception. We don't have the entity framework in the test framework, so we're just going to add that. All right, this guy takes 2 parameters. Let's use, it takes a message. Here's an alias, so you can explain what you're passing. It takes a message. We could use dynamics, and you could go and say new mnemonic string. It doesn't matter what the message is. Get value. Here's a message. And it also takes as a parameter the inner exception. The inner exception is just a new exception. So let's just go here and say new exception like that. So that's a DB update exception that was thrown. And then all we have to do is just pass this guy in here, DB update exception. Right? If these details are too much, and they are, keep your method simple. Just wrap all this up, do control period, and extract method, and say create DB update exception. Look how things are a lot cleaner. This is private down there. We don't care about it. I just want to declare that this is a DB update exception. And that's why I kept this guy very specific about its type. That was the main intent. I don't care about how the DB update exception is. Random details. All right, let's stop here for a second. When you're writing your code, it's like you're writing an article, right? So let's say you're writing articles about how fast airplanes could be, right? And in your article, you're saying airplanes could reach 1,000 miles an hour or whatever, how fast they are. And it's based on the airplane engine. The airplane could be faster or slower. And you're talking about all the different parameters that control the speed of an airplane. It doesn't make sense that while you're writing an article about the speed of an airplane, you go into the details of how airplane engines are created and how many different engines are out there. And it's just details that are taking the reader away from the main purpose of your article, right? So instead, the smart thing would do is to add an addendum to your book, or I think it's appendix or something like that. You go and say, if you want to read more about engines, go to that reference. Just like the Wikipedia. When they mention something and they put a reference there, say, if you want to read more about this, go to this reference. It's exactly the same way when you're writing code. Stay focused. Stay focused. If your method adds 2 numbers, it doesn't make any sense at all to add anything in there other than 2 numbers. So that's the same thing we're doing in here. I don't really care about how the DB update exception has been created. Just say create DB exception, and it doesn't matter what happens after that. Even if you're going to use it once, it's for the readability of your method. Your method should stay readable without scrolling as much as you can. All right, we got that part out of the way. So DB exception. Now let's run the test. So here we say students service, new students service. There you go. And then you could go and say, here's my storage broker. Mock.object. All right, we got the object, and now we're going to await student service dot register student async, and we're passing in the student. All good and dandy. But that's not enough. That's not enough because we want to verify that we actually throw an exception. So what you can do, you could say assert throws asynchronously an exception of type student registration failed exception, like this. Let's pull that reference and control period. Here's a user registration exception. So we're saying assert that this guy actually throws a user registration async exception, right? What you want here next is just an arrow, a fat arrow method that just references this call in here, right? All right. At this point, this guy needs an await because this guy is an asynchronous call, right? And in here, I don't think we're going to need that anymore because it's already asynchronous. So you don't have to really await this because the method knows that you're passing in an awaitable method. So it's already doing that part for you. If you look at the documentation, it's already telling you, I know you're passing in a func that returns a task. So you don't have to await that guy as well. We're going to hide the then here for a second, but we're going to come back to it. We still need the then. This is one of those rare cases when the when and the then start to spill over each other. You're verifying, but you're making the call at the same time. Fine. What some people may suggest is that you put this guy in a variable. This guy, we know that it returns a task, right? We could go in here and take that guy completely out and go here and say task add student register student task, and then you pass in this method like this. That should technically work. Let me add the task part in here, right? And then in the then area, you go and say verify that register student task has actually thrown exception. I think that's better. I like that much more. All right, fantastic. If your method is not returning a task, you might get in a little bit of trouble if it returns a void because you can't do anything about that. So this only works with tasks. That's why it's really cool to use asynchronous stuff. Anyway, so let's go here and say, all right, let's run our test and let's verify that we are throwing an exception. Obviously, this is test-driven development, so this will fail. We'll go red, and then we'll go green, and then we will refactor. So what does the guy say? It says, expected that you throw a student registration fail exception, but in reality, you threw a DB update exception. That means you're propagating exceptions that's related to the underlying technology of storage instead of business-related exceptions. All right? So in that sense, let's go in here. Let's go back to our service and fix that error. We're going to go here and say try and catch. And we are handling DB update exception by sending it off as a student registration failed exception, like this. So we're taking that DB update exception, and I'm going to tell you why I didn't define that in a variable just in a second. I'm just doing just enough to make the test pass, but I'm going to tell you now what happens. So instead, we're throwing new student registration failed exception. So that's a new exception that we're throwing in here. So you can see that your method is turning into this mapper of language between technology and business, even on the exception layer. Even on the exception layer, right? Because that's the whole point of it. If you're really separating by concern, then the categorical concerns here is technology, external, and business, and another external, the input, business logic, and then external dependencies. So you want to make sure that every group of classes speak the same language, a business language. All right, so now we fixed this problem. Let's go back to our tests and let's do Control RT. Lo and behold, this should pass. Did it pass? It passed, right? Let's run all our tests just to make sure everything is good and dandy. All right, now someone might ask me, are you swallowing that exception? You're swallowing that exception. You're not passing in the details for the developers to know what to do with it. So here's what you should do about that. For technical exceptions, you want to log them, but you don't want to propagate them all the way up to your user, because your user has no use of your technical exceptions. If it say you're missing a library or connection string is missing, your user has no idea what to do with that. But if you go to them and say student registration failed exception, and your message says something like an underlying error has occurred, please contact support team, then you know it's a 500 exception, but you're selling a 500 by saying contact support team. The language here is very important when you're communicating technical details to non-technical people. Even to technical people, API failed, contact support team. If it's on their side, if the people that are sending the request in have failed, then you say the request that you sent is malformed. Please follow the standard and documentation to submit successful responses or successful requests. The language between 400 and 500 and 300 and 200, you have to be able to know how to map that stuff. All right, let's go back to our code. So someone says to me, where do I log those details, right? So there's two groups of people here. I am one of the people that say you should go in here and build a logging broker. New item, class, interface, logging broker. And this logging broker will go and wrap and encapsulate the logger library that Microsoft provides out of the box. There's Microsoft extension logger library that you could use. Someone might say, why are you wrapping it? Why don't you just go pass it as a dependency to your class and move on with your life? It's exactly the same reason we did that in the last video, right? In the last video we said we're abstracting away any external dependencies, even if it's Microsoft libraries, because you don't have access to that. So wrap it up in case you decide at any point in time to change your logging mechanism or technology. You don't have to change your business logic. You're interacting with a broker that wraps that away from you, right? Which means, if you go back to the code, which means I only want to log errors, for instance, right? So I'm going to say here and say error. I'm going to pass a string and say message, right? And this error here is a void. There's nothing there. This is my iLogger broker. Now it's up to you how you want to implement that. It doesn't matter. You could wrap that up like from an implementation standpoint. Let's follow through with that. So if you build in a logging broker and your logging broker implements iLogging broker, and then you did that, and then let's say you have some sort of dependency on the logger library. So you have private read-only iLogger, which comes in from Microsoft extensions. Here's your logger, some external library of some sort, right? And then you have that as a dependency passed in, fine, iLogger. And then you're saying this dot logger equal logger, like that. And then whatever you're passing in, you're implementing. So you're saying this dot logger dot error, log error, and then you're passing in some message in there. So you were passing in the message. It doesn't matter how you really implement that. Keep that completely away from your business logic. Keep that completely away, no matter what external library is, no matter how close or far the people who build the library is. If you don't have control over the library, don't touch it. Just extract it, abstract it away, and put your wrapper around it. All right, cool. So we have that. Actually, since this is like a one-liner, for your one-liner constructors or methods, just use a fat arrow just to keep things clean. If you don't need a scope, don't use a scope, right? Go here and say here, a fat arrow, boom. Much, much cleaner code. Right? And since this is a one-liner thing, let's wrap them all together. Even better, prettier code. All right, so we built some logging, right? Let's go back to our service. That was a little bit of a tangent. Let's go back here and say our service now has a new dependency, iLogging broker. And this logging broker basically takes in a message. Someone might ask me right now and say, hey, let me stop you right there. Didn't you say you need to build a broker and then a service in front of this broker to map? I say to them, both for this broker and for this guy. First of all, to this broker, we're passing in primitive type, like a string. So there's no mapping needed here. So you don't have to build a service, right? And the same thing for storage. We own the model that's being persisted in storage. So you don't need to abstract that because you own the model. There's no model that you're going to map to, right? So both cases here, we're good. Once you start using external libraries models, this is when you know that you need to abstract away in a special service. But if you're passing primitive types, or if you own the model that's being persisted in storage, there's no external services needed at this stage. All right, so this is a logging broker, and then this now has become a dependency. Let's break down our stuff. See, even with really high zoom that I have in here, I still can break the code for you and make it look good. So this is logging broker, we got that, and then this dot logging broker equal logging broker. All good. Now we want to verify something. We want to verify that whatever message this guy has is being passed in to the logger. And we have control over that. And I'm going to show you now. This is really beautiful, wonderful stuff. So let's go back to our tests and say, first of all, now our service is starting to fail because we have a new dependency. So let's go here and say private mock iLogging broker, and this is logging broker mock. And let's instantiate that. So logging broker mock equal new mock iLogging broker. I feel I'm going too fast. Feel free to ask questions. So this is iLogging broker, all good and dandy. And then now on your service level, we want to pass in that stuff. So this is this dot storage. I don't know why I didn't use this. These are private class members. So let's go here and say this dot. And then the same thing here. You're going to go and say this dot logging mock dot object. And now this service is happy. If your one line of code, if your one statement takes more than one line of code, please make sure you separate it with a new line. If it doesn't, then just do that. Combine them together. So all that is good and dandy. This dot storage broker mock. All this is good and dandy. This is the one that we care about, however. This guy here will be instantiated exactly the same way. This dot logging broker mock dot object. And now we want to verify a new error. So remember how when we created a DB update exception, we created some random value in here, and we wanted to say make sure that what you're logging is the value that you generate in here. I don't know what value it is. I don't have to know, right? But what I need to know is to verify. Go here in the then and say this dot logging broker mock dot verify broker dot error is passing in, and I like the fact that we're very explicit about this, pass in the DB update exception message. So I'm saying this dot message, not just some message, exactly that message. And make sure this has been called only one time. We don't want to log 100,000 times. Now, if I run my test, things should blow up again. Boom. We expected this to be called once. It was called nonce, and it was called nonce with raka pin whatever random. Like if I run that test again, the error is going to be very different. The message is going to be very different because we are testing behaviors, not particular specific values. So Control RT, let's run that guy again, and lo and behold, blow up, and then a completely different value. Vuku, I don't know what that means. All right, so now let's make it pass. Let's go back to our service, student service, and say, okay, now it's important to have the DB update exception as a variable. And now we want to go here and say this dot logging broker dot error, right, logs in the DB update exception dot message. So I logged my error and then I threw my exception. Now if I go back to my tests and run my test, now our tester is passing. Now our test is saying, yep, you have definitely logged your error and you have definitely cleaned up that stuff. Right? Everything here looks perfectly fine. Right? Okay. So this is pretty much what I want. Now you could go back to your service and log in here your own message. You could go back to your model in here and say whatever you want to say. You want to say option, and you have your constructor, and then you pass in a message and say this guy, let's say at the end here it's option base, and you could pass in a message in here. So this is your message, and you could say string message. So your exception is passing in a specific message to the end user, and if that specific message is static, which should be, then everything now makes sense. Right? You should say could not add this particular student, and then you want to verify that your message that you have passed through your business logic contains the same exact message, right? So that's really pretty much it. I'm going to roll that back just to push the code for you guys to see, but here, exception, right? Let's make sure everything builds and runs and everything. I'm going to continue from now on. I'm going to continue from this project, that student project, to build stuff. But I hope you understood the point here today. The language that you use from a broker perspective versus a service perspective. You don't say delete my student from your school. You say, unregister my student, or deregister, or unenroll, whatever business language you're using. You don't say things like add me to the flight. Maybe you could say add me to the flight. Say I want to purchase a ticket. Purchase a ticket. And when a guy says purchase a ticket, then you go and add them in the database level to flight passengers. So the broker is saying add while the business is saying purchase ticket. Okay, so that's pretty much it. Just another aspect of the fundamentals of building ASP.NET Core applications, test-driven, up to the programming and software engineering standard. We'll continue going on with this series. There's still a lot of stuff to talk about from a security perspective, what your API should look like, what are the responsibilities of the controllers. When do we do the mapping, and what's a view model, and how do we deal with view models, and all that kind of cool stuff we will talk about in more videos Again, I apologize for the long video. There's a lot of stuff I want to teach you guys. If you have any questions, comments, or concerns, feel free to reach out. I will try to answer you as fast as I can. I'm very happy you're following these videos, and let me know if you have any concerns, and please don't forget to like and subscribe. I'll see you in another video. Thank you for watching.